Hey, I hope you like my background here. I call it urban chic. Okay, so what we're doing on example one, it's just flat out substitution. Okay, so we looked at examples where you would end up with a zero over zero. We haven't had an infinity over infinity, but if you can substitute, just substitute. Okay, so this is not going to be a big surprise to you. But on this particular one, we're just going to flat out substitute in the 2. All right, so we have 3 times 2 squared minus 5 times 2 plus 4. Okay, so this is 4 times 3 is 12 minus 10. Oh. It's funny, like this is the kind of thing I see online a lot where people are not doing the order of operations right, and then they start calling it Common Core when it's order of operations. So, but anyway, so 12 minus 10 is 2, 2 plus 4 is 6. So, okay, then same game here. So we should be able to substitute directly in. So 2 cubed plus 1. Now notice I'm not writing the limit notation once I've substituted. Please keep that in mind. That's very important. Notational wise. All right. And so 2 cubed is 8, and 8 plus 1 is 9. And I've got 9 over 3. And there we are. Yay. Okay. Oh, good. Let's substitute in some transcendental functions. All right. So natural log of e divided by 3e. Okay, a little reminder here, okay, because it's been a little while since you've had it. The natural log of e is 1 because this is the logarithm with base e, and it's asking you e to what power is e? Oh, well, I reckon that's 1. So it's 1 over, and both 3 and e are both in the denominator. Both in the denominator. Which isn't 0 over 0. It's a weird number, but it's not 0 over 0, so we don't mind. All right, so here we go. This almost feels like, I don't know, just like it's not even calculus, right? So the cube root of 4 plus 4. It's kind of insulting, especially after those other examples we had that were so hard. So the cube root of 8. There we go. A little trig. All right, so let's substitute in here. We have the sine. Okay, lag of 2 times pi over 6. All right, so 2 times pi over 6. All right, there we are. And so that's the sine of pi over 3. And look, and here's the thing. If you don't remember these, I always just build a little triangle, and I keep one thing in mind. Anything opposite the 30-degree angle, wherever it may be, is a half. Okay, and that's how I keep everything straight. Everything. All right. So on this pi over 6. All right. If I were to draw that, well, pi over 6. Pi is like 180, so it's 180 divided by 3, so that's 60. But I'll keep it. I'm going to draw a 60-degree angle. Okay. And so if that's 60-degree angle, then here's our 1/2 because that's the opposite the 30, like I was saying. All right, and then this is the square root of 3 over 2. I don't know how you keep it straight. I mean, if you've got it memorized, yay. But and of course the hypotenuse is 1 because it's unit circle. But I don't. I mean, I don't. I mean, I can figure them out, so that's what I do. All right, so every single time we ever encounter one, I'm going to draw me a little reference triangle every time. And you're like, well, I've got it memorized. Good. That's not sarcastic. Good. I probably should too. But I don't worry about it because I know I can get to it pretty quick. Okay, so sine of pi over 3, so the sine of 60 degrees, though we're going to stay in radians in this class, most probably exclusively. All right, so the sine is opposite over hypotenuse, so it's the square root of 3 over 2. If it was asking the cosine, that would be 1/2. And if it was asking the tangent, that would be those two divided, which cancels out the 2's and gives you a square root of 3. All right, next we have Substitute in. I haven't written a limit yet on example 1. So this is log base 3. So the base is 3, and the result of raising 3 to a power is 9. That's what that means. So the result of raising 3 to a power is 9. Logarithms are always exponents. So this exponent is 2. Done. It's kind of like that, though. Even though it was all just substitution, we had a little dealing with natural log a little bit there. I think that's brilliant. Cube root wasn't hard. We had a little trig reminder there and another logarithm reminder with a base other than e. I love it.